This is lesson 21-2. Again, it is about special right triangles. This time, it is 30, 60, 90 triangles. It's going to be very, very, very similar to what we did with the 45, 45. The only difference is we're going to have two formulas this time. So let's take a look. We have here a hexagon. Again, it's another quilt block. It says this block is formed from 6 equilateral triangles. So I'm not sure if you see the equilateral triangles not, but each one of them is formed by one of the sides of the hexagon. So equilateral triangles, remind me what we know about them. All of the side lengths are the same size, and all of the angles are what measure? Yes, they're all the same. So that means that they're all 60-degree angles, because the triangle has to have 180 degrees in it. There's 3 angles and they're all the same, so they're all 60. Now it looks like, what is the measure of each angle? We just did that, 60 degrees. What is the measure of each of the angles and the smallest triangles in the hexagon? So they're wanting to know the measure of this. Well, this is 60. And then what's the measure of this angle right here? Just this one. Well, we know that this, the angle that's formed by this equilateral triangle, we know that's a 60-degree angle. And we know that this is a line of reflection, okay, or a line of symmetry. And what does a line of symmetry do? It cuts it cuts this shape into 2 equal shapes, okay? And if these 2 shapes are equal, then what's true about this angle right here and this angle right here? Well, they're going to have to be congruent. So if the big angle is 60 degrees, then how much is each one of those little angles? That's right, they're each 30. Okay, so now we have a 60-degree angle, a 30-degree angle. That makes 90 degrees. That means this angle down here must be a right angle. And again, that's where we get the 30, 60, 90. So what are the measure of each of the angles of the smallest angles in the hexagon block above? 30, 60, 90. And the explanation is we took the equilateral and we found one line of symmetry. That cuts it into 2 equal parts. The smallest triangles are special scalene. If all 3 angles are different, then all 3 side lengths are going to be different. They're often called 30, 60 right triangles. How can you determine which leg is shorter and which leg is longer using the angles of a triangle? Well, that's pretty easy. The hypotenuse will be opposite the 90-degree angle, and it's also the longest side of the triangle, but we don't call the hypotenuse a leg. Be very careful and get these vocabulary words straight. So this is a leg, this is a leg, this is never called a leg. It's either a hypotenuse or a side. Okay, so if this is, let's say, the 60-degree angle, and this is the 30-degree angle, then the side or the leg across from the 30-degree angle will be what we call the short leg, and the one across from the 60-degree angle will be the long leg. Okay, so that's how we will refer to these: the long leg, the short leg, and the hypotenuse. It's very important that you get those terminology straight, because that's how we know that's how we write our formulas. So again, across from the 30 will always be the short leg, across from the 60 will always be the long leg, and across from the right angle will always be the hypotenuse. It says if each side of the hexagon quilt block is 4 inches, each side of the hexagon is 4. So this whole side right here is 4. That's what they tell me. Then how long is the shorter leg in the 30-60? Okay, so here's the 30. So this whole thing is 4. Or again, here's the 30. And then this whole thing is 4. So that means this piece is 2 and this piece is 2. So across from the shorter leg, across from the 30-degree angle is the shorter leg, and it has a measurement of 2. Explain your answer. It's 2. And the explanation is it's half of 4. And it's across from the 30-degree angle. What is the relationship between the length of the hypotenuse and the length of the shorter leg in a 30, 60, 90 triangle? Explain your answer. What is the relationship between the length of the hypotenuse? So they want to know how long is the hypotenuse. They want to know how long the hypotenuse is. Well, that right there is the side of this 60 of this equilateral triangle, right? So this equilateral triangle right here, notice this is 4. So this distance right here, the one that I'm squibbling on, that is also 4. Well, that may be the side of one of those equilateral triangles, but it's also the hypotenuse of that triangle. So we know the hypotenuse is 4. And we know it's 4 because of the equilateral triangle. Okay, now it wants us to look for a pattern. Okay, so the length of the hypotenuse, let's go to where we knew it was. The length of the hypotenuse was 4, and the shorter leg was 2. And if we know that it's 4 and 2, then we can use the Pythagorean theorem to find out this leg, which is opposite the 60-degree angle. That's the 30-degree angle. So this is the long leg over here, long leg. So can I call this x? I hate using LL. So x squared plus 2 squared is equal to 4 squared. So x squared plus 4 is equal to 16. Subtract 4 from both sides, and x squared is equal to 12. Take the square root of both sides, and x is equal to 12 is equal to 4 times 3, and then we can take the square root of 4. We can separate those into 2 different radicals, and the square root of 4 is 2. So we end up with the length of the longer leg is 2 square roots of 3. Now, if the relationship here between 4 and 2, that's half, right? That 2 is always going to be half of that 4. Remember why it was half of that 4? Because the 4 was across the base right here. It's also what we call the radius of that hexagon. So if that changed to, if this was 8, then this piece right here would be half of that. It would be 4. If this piece right here was 6, then this piece right here is going to be half of that. It's going to be 3. Okay, so the it looks like the hypotenuse and the shorter side are in a relationship to where the shorter is always half of the hypotenuse. So that's going to be 4, and that's going to be 3. And if this 3.5, I believe, is half of 7, and 1 is half of 2. So we've got that part done. So we know, let's make sure we write down. So we know that if you take the short leg, I'll use SL right now, the short leg, and you multiply it times 2, you'll get the hypotenuse. The short leg times 2, and that's going to equal the hypotenuse. The short leg times 2, the short leg times 2, the short leg times 2. That's how you get the hypotenuse. Now notice what the long leg was. The long leg was the same, this number right here with the square root of 3 on it. Now do you think that was a coincidence? I don't know. Let's do another problem real quick. And if it comes out to be the same thing, we'll chalk it up to not being coincidence. So on this one, this is 4 and this is 8. And we're trying to calculate this measurement right here. So if this is the measurement, then we're going to know that x squared plus 4 squared is equal to 8 squared. So x squared plus 16 is equal to 64. Subtract 16 from both sides, and 50, oh, I don't trust myself to do that. Y'all laugh at me, but I got old lady brain. 64 minus 16 is 48. And now we take the square root of both sides, and x is equal to the square root of 48. Well, that's not a square root of 3, but if we simplify this, 48 is the square root of 16 times the square root of 3. And if you take the square root of 16, you get 4. And what did we get right here? 4 square roots of 3. So we got the same thing twice, so maybe it's not a coincidence. So maybe this is 3 square roots of 3. And maybe this is 3.5 square roots of 3. And maybe this is 1 times the square root of 3. And it absolutely is. So here is the other formula. You take the short leg and you multiply it times the square root of 3. And that's equal to the long leg. So notice that you have to know the short leg. The short leg is what you have to know in order to figure out the hypotenuse, in order to figure out the long leg. The short leg is the one that we use in the formula. So these are your two formulas. Short leg times the square root of 3 is the long leg, or you could say long leg equals short leg times the square root of 3. And the hypotenuse is the short leg times 2. So there's your two formulas. You need to get those memorized. Actually, you don't have to get those memorized because they are on your formula card. If you'll give me, well, I tell you what, when I open the next video for the answer key, I will then show you the formula sheet and show you where it is. Now here they want us to do the ratio of the length of the longer leg to the length of the shorter leg. So they want the long leg to go on top. So 3 square roots of 3 and the short leg on bottom. That comes out to the square root of 3. 4 square roots of 3 over 4. That comes out to the square root of 3. 2 square roots of 3 over 2. Square root of 3. So I think that's, if you ever are trying to figure out, one of the missing sides, if you have either the long leg or the short leg, you can use this ratio. Long leg over the short leg equals the square root of 3. You can use that ratio. Okay, what pattern did you notice in table 4? We've talked about that. Write a verbal rule finding the length of the longer leg of the right triangle. We just did that one already. We said the long leg is equal to the short leg times the square root of 3. Write a verbal rule. The hypotenuse is equal to the short leg times 2. Let S, oh, I hate using S. My S's look like 5s. I usually use X, but They said use S. Let S be the length of the short leg of the right triangle. Use the Pythagorean theorem to derive the formula. Okay, so if we say S squared plus, and the other one is the long leg, and the long leg, remember, is S square roots of 3. That's squared, we get the hypotenuse squared. And then that's going to be S squared plus 3S squared. What? The square root of 3 squared. Remember, those will cancel each other out. And yes, these are S's, not triangles. I can't draw, this is the cursive letter S. And I can't do S's like that because they look like 5s. Equals H squared. So this is 1S squared plus 3S squared. That's 4S squared. And that's equal to H squared. Take the square roots of both sides. The square root of 4 is 2. The square root of S squared is S. And there's the formula for the hypotenuse. 2 times the short leg equals H. One of the students in Miss Jones's class wrote the proportion to find the unknown leg. Did the student correctly find the length? Okay, well, I'm not going to look at theirs. I'm going to set theirs up first. Now, remember we said up here in the table, we did the long leg on top, the short leg on bottom. So the long leg on top, short leg on bottom, that's supposed to equal the square root of 3. Now, they did the square root of 3 over 1. Yes, you can put any number over 1, so I would agree with what they did. Cross multiply, and you get x is equal to 5 square roots of 3. That's how they did that. All right, so not a lot of practice for you. Not a lot of practice at all. But don't worry, in upcoming lessons, you will get lots of practice, because what you'll find is that 30, 60, 90 triangles are used a great deal in problems about area, and problems about volume, and problems about surface area when we get to those. So you'll be using 30, 60, 90 formulas and 45, 45 formulas and the Pythagorean theorem a lot for the rest of the course. So my next video will be going over the answers to these, and I will also pull up the formula sheet and show you how to utilize that.